So good morning or good evening, wherever you are today. In this video, I want to talk to you about graphing the tangent curve. Tangent is also a periodic curve. It's a wave, but it's not the kind of wave that we're used to. We're used to waves going in an up and down fashion. This is an asymptotic wave because there are asymptotes. Now the asymptotes are at the values of pi over 2. So pi over 2, then would come 3 pi over 2, 5 pi over 2, 7 pi over 2. To the left, negative pi over 2, then negative 3 pi over 2, negative 5 pi over 2, and so on and so forth. The intercept at the origin is where tangent begins. And then over here, this next intercept is pi. Then would come 2 pi, 3 pi, 4 pi, and so forth. Over here is negative pi, then negative 2 pi, negative 3 pi, and so forth. So this is the parent graph for tangent. So let's look at a few things about tangent. Tangent is different than sine and cosine in a few ways. Well, number one, it's not bounded, it's asymptotic, which means amplitude doesn't really have any meaning here, whereas amplitude does have meaning for sine and cosine. The period of tangent is a bit different also, whereas sine and cosine have a period of 2 pi naturally. Tangent has a period of pi instead. So one tangent wave completes every pi interval. To calculate a new period, you take pi and divide it by b. Now the key points for the tangent curve, for this curve here, are 0, 0, pi over 4, 1, negative pi over 4, negative 1. And the asymptotes are pi over 2, negative pi over 2, and so forth. Those are the vertical asymptotes. So here's what I want to be able to do. I want to be able to graph this curve. Y equals 2 plus 3, tangent of pi over 2x. Let's talk about the transformations first before we go to the graph. So notice inside the tangent is pi over 2 times x. And this means the b value is pi over 2. So to calculate the new period, I have to take pi and divide it by pi over 2, and I get the whole number 2, which is an integer. So every 2 values is when the wave repeats. Now, the 3 on the outside changes the y values. It's a vertical stretch. So we're going to multiply all the y values by 3, and after we multiply them by 3, we add 2 to the y values to give it a vertical shift. Think order of operations. Multiplication comes before addition. That's important. So we're still going to follow the order of operations. Now if we do this process, first thing we have to do is we have to take all of the x values and we have to divide the x values by pi over 2. So here's the original key points. We have to take all of these x values, 0, pi over 4, negative pi over 4, even the vertical asymptotes, and divide them by pi over 2. So when we do that, we end up with these new key points. And I've only listed 3 of them, but they are 0, 2, 1/2, 5, negative 1/2, negative 1. So okay, where's this 2 coming from? Well, the y value originally here is 0. That's the y value. Multiply 0 by 3, which is 0, and add 2. And so that's why the new key point is 0, 2. Then, pi over 4, 1, the y value is 1. Multiply 1 by 3, and then add 2, and so we get 1/2, 5. Using this on the other key point, we get negative 1/2, negative 1. Oh, I forgot to write the comma, but it's there. The comma's there. And then the vertical asymptotes we divide by pi over 2, and so we're going to get the following graph. The vertical asymptotes are now at 1 and negative 1. The origin got shifted up 2 units, so this is 0, 2. And what used to be at pi over 4, 1 is now at 1/2, 5, and now at negative 1/2, negative 1. And that is the graph of tangent. So all of the transformation rules that we learned in Chapter 1 still apply. Again, this is an asymptotic curve, so amplitude doesn't apply here. Amplitude really only applies to sine and cosine. And that is how you graph a tangent curve. God bless you, wherever you are today.